Okay, so in this video I'm going to be going over the Chapter 3 review. Number 1 is having me start off by finding the exact value of the expression sine 190 cosine 70 minus cosine 190 times sine 70. So remember, I'm allowed to use my reference sheet on this. On this one, this is got a minus in the middle, and then the sines and cosines switch. So if I look at my sum and difference formulas, I'm looking for minus in the middle. So these are my two minuses, and then sine and cosine are together. So this would be a sine difference formula. So alpha is my first angle, beta is my second angle. Part A is asking me to identify my alpha and beta. So alpha is 190, beta is 70. B wants me to write the expression as the sine of an angle. So this was subtraction. So I'm going to do sine of 190 minus 70, which is just sine 120. Then part C wants me to find the exact value of the expression. So remember, if I was to graph this, sine 120 is right here. The part from the x-axis to my angle is 120, and this part right here is 60. And remember, that part is called my reference angle. Sine at 60 degrees is the square root of 3 over 2. And then I need to remember if sine is positive in the second quadrant. So we have the mnemonic, all students take calculus. All are positive in the first quadrant. Only sine is positive in the second. Only tangent is positive in the third. And only calculus is positive in the fourth. We're in the second, so this one is positive. Number 2 wants me to verify the identity. And it has a sum and difference of sine on the left side, and then it says tangent alpha plus tangent beta equals tangent alpha minus tangent beta. So what I'm going to do to start this off is I'm going to use my sum and difference formulas on the left side to break up the sign. So on the top I have a plus, so that means it's a sum. I'm going to have sine of alpha cosine beta plus cosine alpha sine of beta. And then on the bottom, sine of alpha cosine beta minus cosine alpha sine of beta. This still equals my original trig function. So I have tan of alpha plus tan of beta over tan of alpha minus tangent of beta. So what I can do next is I can go ahead and if I multiply my numerator and denominator by the same fraction, it counts as multiplying them both by 1. So I'm going to multiply by 1 over cosine alpha, cosine beta, and this is just to get tangents in there. And then this is all over 1 over cosine alpha, cosine beta. So my numerator is going to get multiplied by this fraction, and my denominator on the left side is going to get multiplied by this fraction. So I'm going to have sine of alpha cosine beta over cosine alpha cosine beta plus cosine alpha sine of beta over cosine alpha cosine beta. And the reason I picked cosine alpha and cosine beta on the denominator is tangent only works with cosine on the denominator. So I'm putting both cosines in there to take care of them all at once. Then on my bottom part of the fraction, I'm going to have sine of alpha cosine beta over cosine alpha cosine beta minus cosine alpha sine of beta over cosine alpha cosine beta. This still equals my original right side of the equation, so tangent alpha plus tangent beta over tangent alpha minus tangent beta. On my fraction, I can simplify. These cosine betas will cancel out. These cosine alphas will cancel out. On the denominator, the cosine betas cancel out, and the cosine alphas cancel out. So I have, on my top, I have sine alpha over cosine alpha plus sine beta over cosine beta, sine alpha over cosine alpha, and sine beta over cosine beta. So I am going to write these out. So this equals tangent alpha plus tangent beta So I have one more final step because I need to always show that it equals. I ran out of room to keep going straight down, so I'm going to show this arrow. I have tangent alpha plus tangent beta over tangent alpha minus tangent beta. And this equaled the right side I originally had. Oops, what am I writing there? So number 3 is telling me to find the exact value of each of my 3 given sum formulas, sine, cosine, and tangent. And it gives me that tangent of alpha is 20 over 21. Pi is alpha is between pi and 3 pi halves, and then it also gives me the value of cosine beta. So if I draw this out, tangent of alpha is between pi and 3 pi halves. So that would put this in the third quadrant. Remember, tangent is y over x. So my y value is 20 and 21. Because this is in the third quadrant, I know these are both negative. And this is for my alpha. For beta, I'm going to do beta in red. It tells me this one is between pi halves and pi. So I'm going to draw this on the same. It tells me cosine is negative 5 over 13. Remember, cosine is x over r. So I'm going negative 5 to the left, 13 for my hypotenuse. Then I just need to figure out my third side for each of those. On the blue triangle, if I use the Pythagorean theorem, I can get that third side, which will be 29. I'm not going to show me doing the Pythagorean theorem, but I promise you it gives you 29. On the other one, if I use the Pythagorean theorem, it gets me 12. And the 12 is positive because our coordinates in the second quadrant for x are positive. If you've forgotten, remember, first quadrant is positive, positive. Second quadrant is positive, negative. Third is negative, negative. And the fourth is positive, negative for x and y. Okay. So part A wants me to find the sine of alpha plus beta. So I'm plugging into the sum formula for I'm plugging into the sum formula for sine. So this is sine of alpha, cosine of beta, plus cosine of alpha, sine of beta. So I want to go ahead and find my values for those four trig functions. Sine of alpha is y over my radius, so on the alpha triangle, that's the blue one, I'm going to have negative 20 over 29. Cosine of beta is coming from the red triangle, and that was actually given to me. That's negative 5/13. I'm adding cosine alpha. Alpha was the blue triangle. Cosine is negative 21 over 29. And then sine of beta is coming from the red triangle. This is 12 over 13. So then I want to add those together. I can add them on, or multiply and then add. So I can do this all at once on my calculator. So it gives me a decimal. If I go to math fraction, it turns it back into a fraction for me, which gives me negative 152 over 377. I want to do the same thing for cosine. So cosine, my sum formula here is cosine alpha, cosine beta, minus sine alpha, sine beta. And I'm getting this off of the reference sheet. So cosine alpha is from the blue triangle. That is negative 21 over 29. Then cosine beta was the one that was given to me, negative 5/13. Sine alpha is on the blue triangle, negative 20 over 29. And I have a double negative here because I have the negative from the formula and the negative from the 20 on the triangle. Then I have sine of beta, which is 12 over 13. I can type this into my calculator. Then turn it back into a fraction, which gets me 345 over 377. And then I want to do the same thing for my tangent alpha plus beta. So I'm going to plug into my sum of tangents. This formula is the tangent alpha plus tangent beta over 1 minus tangent alpha plus, times tangent beta. So I want to plug into these. Tangent alpha is the one that was given to me. That was the 20 over 21. Then I have my tangent beta, which is going to be 12 over negative 5. Over 1 minus tangent alpha is, again, the one that was given to me, the 20 over 21. And tangent beta is the 12 over negative 5. So I can simplify this by hand, or I could type this all straight into the calculator. If I type this into the calculator straight as it is, I want this top part all in parentheses and the denominator also in parentheses. So, because that's all on the screen. Then I go math fraction to turn it back into a fraction. It gets me negative 152 over 345. Okay. Moving on. The next one tells me that tangent 24 over 7 lies in quadrant 3. Find each value. So again, I want to sketch out another picture. Quadrant 3 is this one. I know tangent is y over x, so this is going to be 24 and 7. Because it's in quadrant 3, both of these values are negative. I want to figure out my hypotenuse. I could use the Pythagorean theorem, and that will get me the 25 right here. Then I can find each value using the double angle formulas. I can tell I'm using double angles because it has 2 thetas for all of the, oops, this one should be 2 theta. I'll fix that for yours. It has the double angles for all of these. So I am going to plug into them. This first one, the double angle formula, is 2 sine theta cosine theta. So I'm going to have the 2 out front. Sine of theta is negative 24 over 25. And cosine of theta is negative 7 over 25. Then I just want to type this into my calculator. Go to math fraction, and it gets me 336 over 625. My cosine double angle formula is cosine squared minus sine squared. So I know from the last problem that cosine was negative 7 over 25. And I know sine is negative 24 over 25. Remember, I want this to be in parentheses before I take anything out with that negative, because this one squared is just going to disappear. So I'm going to type this into my calculator. I go to math fraction, and it gives me negative 527 over 625. Then for my tangent double angle, this one is 2 tangent over 1 minus tangent squared. Tangent was the one that was given to me in this problem, so I want to make sure I get that value exactly right. It was 24 over 7. So I have 2 times 24 over 7 over 1 minus 24 over 7 squared. Again, I can type this straight into the calculator if I put the top in a set of parentheses and the denominator in a set of parentheses. I go to math fraction, and it gets me negative 336 over 527. Okay. Number 5 just wants me to write out the expression as the tangent of a double angle. It doesn't actually want me to solve this one. What I would do is, this is following that form right there. So I know that my original theta is 2 pi, or is just pi thirds. So I'm plugging in for tangent, and then 2 times my theta, which is pi thirds. So this would just give me tangent 2 pi thirds. Okay. Number 6 wants me to verify the identity, and then that's all I have to do on this problem. It's giving me sine theta plus cosine theta squared equals 1 plus 2 sine 2 theta. So I'm going to work with my left side because I have more terms to work with. If I rewrote this out, it's the same thing as saying sine theta plus cosine theta times sine theta plus cosine theta. So I would want to distribute and FOIL over here. My two first terms are sine theta times sine theta, which will get me sine squared theta. Then I have sine theta times cosine theta, which gets me sine theta cosine theta. I have cosine theta times sine theta. I'm going to write the sine theta first just for consistency. I spelled cosine theta wrong. Then I have cosine theta times cosine theta, which gets me cosine squared theta. And it still equals the 1 plus sine 2 theta. On the left side, I can go ahead and combine like terms. I have two of the same term in the middle. So I'm going to have sine squared theta plus 2 sine cosine theta plus cosine squared theta equals the 1 plus sine double angle. Then I could rearrange my terms. So if I think about this, I have sine squared theta and cosine theta being added together. Remember, if I looked at my reference sheet, my Pythagorean identities, sine squared plus cosine squared equals 1. So those together are going to give me 1. And then I have 2 sine theta cosine theta. If I look, that is my double angle for sine. So I can replace that with sine 2 theta. And it equals my original equation, so I am, or my right side of the equation, so I am good. Okay. Number 7 wants me to use the half angle formula to find the exact value of cosine 3 pi eighths. So remember, for this one, I want to take this and multiply by 2 to figure out which angle I'll be using. This gives me 3 pi fourths, which I need to remember where this is on a coordinate plane. It's right here. So over here, my reference angle is going to be pi fourths, and cosine is going to be negative in this quadrant. So cosine of pi fourths is regularly square root of 2 over 2. But in this quadrant, it's negative. So I'm going to use the half angle formula. So I have the square root of 1 plus cosine 3 pi fourths over 2. This is going to be a plus on the outside, because, or positive on the outside, because 3 pi eighths is really, let me draw this one in red. 3 pi eighths is like right here. So that is in the first quadrant, so it's still positive. When I go to evaluate the 3 pi fourths, however, that will be the one that's negative. So I have in my square root 1 minus square root of 2 over 2 over 2. So then I get the square root of, I'm going to multiply the numerator and denominator on this one by 2. So it turns into 2 over 2 plus the square root of 2 over 2 over 2. I can rewrite this 2 on the bottom as a 1/2 and multiply it. So I would get 2 over 2 plus the square root of 2 over 2 times 1/2, which gets me 2 over 4 plus square root of 2 over 4. Since they are both over the 4, I can rewrite this as 1. And for this one, I can go ahead and, when did I change that negative into a positive? I can go ahead and square root the 4. So I have the square root of 2 minus the square root of 2 over 4 for my final answer. Okay, so moving on to the next one. This one wants me to find all of the solutions to the equation sine x equals -1. So remember, if I'm on a unit circle, this is the only place I will ever get sine to equal a negative, is on one of those 90-degree measurements. This one is 0, -1, which is 3 pi halves. So it will happen at 3 pi halves, and then since it wants all of my solutions, this is going to keep repeating. So it's going to be plus 2 pi n, where n is any integer. And the 2 pi is for every circle it repeats. Okay. Number 9 is a similar equation. It wants me to solve on the interval 0 to 2 pi. So this one has a very defined set. What I can do is figure out where cosine is square root of 3 over 2. This is at pi 6. So I have 2x equals pi 6. And that is where it's positive first in the first quadrant. Remember, cosine is also positive in the fourth quadrant. So I'm going to want to solve it for 2x equals 11 pi 6. Because right here is 11 pi 6 for cosine. Because you just take the pi 6 and subtract from 12 pi 6, which is 2 pi. So on the first one, I also need to have my plus 2 pi n. And I also need to have that on my second one. On the first one, I want to go ahead and divide everything by 2. So that gets me x equals pi 12ths plus pi n. And my second one, I get x equals 11 pi 12ths plus pi n. So I want to make sure all of my answers are less than 24 pi 12ths, because it needs to be inside this range. So I'm going to plug in values for n. On my first equation, I'm plugging in n equal to 1. So I have pi 12ths plus pi, which is the same thing as saying pi 12ths plus 12 pi 12ths, which gets me 13 pi 12ths. This works. Then I have n equals 2, so if I plug this one in, I'm going to have pi 12ths plus 24 pi 12ths. I can already tell because this one is over the 2 pi right here. This one's not going to work. I'm going to do the same thing for the equation down below. So I have my n equals 1. I have 11 pi 12ths plus 12 pi over 12, which gets me 23 pi 12ths. That one is below 24, so this one works. Then I can do the same thing for n equals 2. I have 11 pi 12ths plus 12 pi 12ths. Nope, this one's 24 because it's 2. It's already adding over 24. This one's not going to work. So my final answer is these two. And then if I plugged in 0, these two would also work. So I'm going to write them in order. I have pi 12ths, 11 pi 12ths, 13 pi 12ths, and 23 pi 12ths.